Alrighty, welcome to the end of chapter 11. This is section 11.8, rational equations. So we're taking those rational expressions that we had that were just by themselves and we're putting them into equations. So that means you've got an equal sign and then you've got probably some rational expression on the left and the right side. So first of all, rational equation is an equation with one or more rational expressions. Basically, I just said that. So you're taking the rational expressions and you're sandwiching them on either side of an equal sign. So over here you could have some nasty fraction stuff, and over here some nasty fraction stuff. And you might even have plus or minus, some other nasty fraction stuff. Remember extraneous solutions. So back before when we were just dealing with expressions, we had some things that you could not have. You could not divide by 0. So there were certain restricted domains, there were certain numbers that were not allowed. And so in the act of solving an equation, if you find out one of those solutions, when you plug it back in, it results in a 0 in the denominator, then you have to throw it out. It's not a solution. So an extraneous solution is something which seems like it works, but when you plug it back in, you actually get a 0 in the denominator. So extraneous solutions, you'll solve and you'll get an answer, but you always have to plug it in and check. Okay, then work problems and rate problems. This is not so much a vocabulary word as just a classification of a bunch of problems. So there's a whole class of problems that are using rational equations that involve the rate that work is done, and there's a whole other class of problems involving the rate of change, so distance, speed, and time. And so a lot of the word problems that you're going to get are either going to be work problems or rate problems. Some problem solving tips, and then we'll do our examples. First one, if a rational equation is a proportion, you can cross multiply. So by that I mean, if you have on the left side a over b, and on the right side c over d, which means there's just a single fraction on this side and there's just a single fraction on this side. Nothing added or subtracted over here, nothing added or subtracted over here. So you have a fraction equals a fraction, then it's just called a proportion, and you just cross multiply, right? A times d equals b times c. Again, the reason cross multiply works is because technically you're multiplying this side you're multiplying both sides by d. Okay, but here they cancel out. So it's like the d got moved up over here, and you're multiplying both sides by b, but here they cancel out. So it's like that b got moved up over here. And anyway, you get cross multiply, you get a times d equals b times c. So the shortcut that you're taught is cross multiply, but it's good to know that you're really following the golden rule. That's why it works. Okay, if your problem is not a proportion, you can make it a proportion by finding a common denominator. So suppose you've got like 5 plus 2/3 equals x over 6, right? So you can't, this is super easy. Let's just change this to, 5x. Okay, make it more complicated. The point is, you can't cross multiply because on this side you have two things, yeah? Not just a fraction and not just a fraction. But if you could combine these together somehow, for example, multiply this guy by 3 over 3, okay, then what would you have on this side? You'd have 15x plus 2, 15x plus 2 over 3. Now you have a common denominator, right? So on this side you have a single fraction, and then on this side you still have your x over 6. So now you have a proportion because you have a fraction on this side and a fraction on this side. You can cross multiply and then you can solve. So if you start with something that's not a proportion but it is a rational equation, you can get a common denominator to verify or to get it into this form and then cross multiply. Okay, always plug in and check your answers to make sure they're not extraneous. That's just going back to that vocab word. You can't have a 0 in the denominator. And then the last thing, always check the answer to word problems for common sense. So this one has a lot of problems involving inverse variation, and therefore it will say something like, if it takes 10 people 1 day to paint a room, how long will it take 20 people? Okay, so your natural thought process might be like, oh, twice as many people, it will take twice as much time, 2 days. But that's totally insane, right? If you have more people working on a job, it should take less amount of time. So with inverse variation, make sure you're checking common sense for these kind of word problems, and don't just jump to conclusions without thinking about it. Okay, for our examples, we're going to solve each equation and then state any extraneous solutions. So here we've got a simple proportion on a simple proportion. So we're going to solve this by cross multiplying. 2 times c is 2c. 5 times c plus 3. I'm going to show my work. C plus 3. Okay, distribute. 2c equals 5c plus 15. Maybe I'll go minus 5c minus 5c, negative 3c on the left side equals 15. Divide both sides by negative 3, and you get c equals negative 5. Okay, we got to plug this back in and make sure it worked, yeah? So 5 over negative 5 equals 2 over negative 5 plus 3. This side is negative 1. This side is negative 1, so it works. So c equals negative 5 is a solution. Okay, let's try this one, for example. Again, simple fraction here, so I'm going to cross multiply. 3 times x plus 8, that's that one, equals 5 times x plus 2. Cross multiply, get 3x plus, not cross multiply, sorry, distribute. 3x plus 24 equals 5x plus 10. Subtract 3x from both sides. That's going to give me a 2x on this side. Subtract 10 from both sides. That's going to give me 14 on this side. So I get x equals 7. Now, if I'm going too fast, of course, remember that you can pause these videos. But also recognize that these are things that we learned at the beginning of the year: how to distribute, how to subtract 10 from both sides, how to divide both sides by 2. See, I didn't really show divide by 2, divide by 2. I know that I always emphasize that you show your work, and you've got to balance the emphasis on showing your work to not make mistakes with the emphasis on going reasonably quick, you know. So if it's something that you've practiced and you're getting good at it, you want to go a little faster. So you don't want to be sitting there showing your work on 2 plus 2 is 4. So similarly, I'm not going to dictate to you when and where you stop showing your work, but if you feel comfortable going through these processes and you can do them without making too many mistakes, then you can start to reduce the amount of work that you show on these things that you're now good at. Okay, last side here. I guess we'll try both of these. So this one's just numbers, this one's going to be a little bit easier. So here we've got 2 fractions on one side and only 1 on the other. So there's nothing we can cross multiply because we don't have proportions. We need to get on this side a common denominator. Now we've got a 3 and a 6. So the common denominator between a 3 and a 6 is a 6. So this one's already good to go. To get a 3 up to a 6, we're going to have to multiply here by 2 over 2. Okay. So now this side is going to have a denominator of a 6, of course. This side, let me just copy it down, q plus 4 over 18. Now over here we've got 2q minus 1 minus 2q. Well, 2q minus 1 minus 2q, of course those 2q's and those 2q's cancel out. Now if I cross multiply, I get a negative 1 times 18. That's negative 18 on this side. And then over here I'm going to cross this way, I'm going to get 6 times q plus 4. That's going to give me negative 18 equals 6q plus 24 minus 24 minus 24. 6q here equals negative 18, negative 24 is going to give me negative 42. Divide by 6, divide by 6. Q equals negative 7. Now we got to make sure this is a solution, so we plug it back in up here. And there's no q in the denominator anywhere, so we don't have to worry, it's not going to be a problem. Alright, last example of the entire chapter. We're almost there. To make these work, we're going to need a common denominator, okay? But there's nothing in common between a 2x plus 1 and a 2x plus 3. So the only way to get the common denominator is to multiply each one by the other one. So I'm going to have here 4x over 2x plus 1, close parentheses. Then I'm going to have to multiply by 2x plus 3. Here I'm going to have to multiply by 2x plus 3. So this first piece is going to get multiplied by 2x plus 3 over 2x plus 3. Then I'm going to subtract. Here I've got the 2x plus 3. The part that I'm missing is the 2x plus 1 in both the top and the bottom. So I've got the 2x right there. And I'm missing the 2x plus 1 here. Equals 1. Okay, now on this side, I'm going to combine terms and I'm going to distribute in the numerator. So that's going to give me 8x squared plus 12x minus, here it's going to be 2x times 2x is 4x squared. This minus sign distributes, so I'm going to have minus again. 2x times 1 is 2x. Okay, equals 1. And then in my denominator, I still have here, let's go ahead and multiply this out because I'm going to be comparing it to this quadratic expression, so some of my x squareds are going to cancel and need to get combined. So 2x plus 1 times 2x plus 3. 2x times 2x is 4x squared. 2x times 3 is plus 6x, 1 times 2x is plus 2x, and 1 times 3 plus 3. So there we go. This is looking pretty crazy. I'm going to cross multiply now. This is like 1 over 1, yeah? So this stuff right here is going to multiply up to the other side, and then I'll combine like terms. So 8x squared, I'm going to combine this, oh man, 8x squared minus 4x squared. That's going to give me actually just 4x squared. So I'm going to combine this one and this one. Then I've got here 12x minus 2x. That's going to give me plus 10x, okay, equals, now all this stuff is going to give me 4x squared. Here I'm going to combine these together and get plus 8x and then plus 3. Now we got super lucky. The 4x squared and the 4x squared canceled out. So the solution is going to be non-quadratic, yeah? We're just going to subtract 8x, subtract 8x, and then we're going to get 2x equals 3, and the solution x equals 3/2. Okay, so that was super lucky. If it turned out that the x squared part did not perfectly cancel out, then what would we have to do? We would have to solve this using the quadratic formula, or completing the square, or factor and cancel. So the thing about these problems is they really utilize all the different techniques that we have learned. Let's plug 3/2 back in. You can see if you plug it in, it doesn't cause any problems. There's no zeros in the denominator, so it's a viable solution. But it's crazy to think about that you can get some interesting results that end up using the quadratic formula when you started with a rational expression. So these problems are longer and a little more involved, so take your time, go through bit by bit. Distribute, common denominators, factor and cancel, cross multiply, combine like terms, work backwards. It really does use all the different techniques that we've learned this year. But congratulations, you've just finished the last video for chapter 11, maybe for the whole year, if you're lucky. Alright, see you in class.